In the mid-20th century, the world found itself in a state of global confrontation. The United States and USSR competed not only in military power, but also in scientific, technological, and ideological superiority. The confrontation became known in the history as the Cold War. In 1957, the USSR launched the first artificial Earth satellite, Sputnik 1. For the United States, it was a shock. How a country lying in ruins after the bloodiest war in history had managed to launch first satellite into space just 12 years after the war ended, demonstrating technological superiority in space. And then also be the first to send Yuri Gagarin into space in 1961. This was unimaginable. America needed not just to catch up, but to do something that would eclipse the achievements of the USSR, because the flight of the first American in space, Alan Shepard, on May 5, 1961, no longer looked like something incredible to the public, especially since it was a suborbital flight. A bold goal needed, and the answer came quickly. On May 25, 1961, the President of the United States, John Kennedy, delivered a historic speech at Rice University in Houston.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
The challenge was thrown. There was no turning back. Why was it possible to achieve something so incredible, landing on the moon? And why, after more than 50 years, have people still not returned? How did it happen that we have more advanced technologies, computers, microchips, cameras, the internet, and a ton of all sorts of fashionable equipment, but have still not been able to repeat it? Could it be that the flights were a simulation and a successful project to bankrupt the USSR? More on that a bit later. The Apollo program received unprecedented funding. Even by today's standards, it was an enormous amount of money. The states allocated about 4% of the country's entire federal budget to the program. For comparison, today, NASA receives less than 0.5% of the budget. In the 1960s, more than 400,000 people worked on the lunar program. Engineers, scientists, technicians, military personnel, contractors. The entire country was effectively involved in one giant project that became a national idea. The goal was simple and clear: fly to the moon, land and return. Nothing more. There was no need to build permanent bases, no need to extract resources, no need to create complex infrastructure. It was only necessary to prove that America was capable of doing what no one had ever done before. Before Apollo, there were the Mercury and Gemini programs. The Mercury program was the first US crewed space program and tested whether a human could survive in space. There was one astronaut on board. The flights were short, from 15 minutes to several hours. The goal was to put a person into orbit and return them safely to Earth. The Gemini program became the logical continuation and preparation for the moon. There were already 2 people on board. The flights lasted up to 14 days. And the main tasks were to learn docking in space, extravehicular activity, and the long-term stay of the crew in orbit. All of this made the Apollo flights possible. On July 20, 1969, astronauts Neil Armstrong and Buzz Aldrin landed on the surface of the moon. The mission lasted only a few days. The astronauts spent less than 24 hours on the moon, but this turned out to be enough to change history, inspiring millions of people around the world that even the most ambitious goals can be achievable with the proper perseverance. What happened next? Apollo 11 was followed by 5 more successful landings: Apollo 12, Apollo 14, Apollo 15, Apollo 16, and Apollo 17. Astronauts brought back hundreds of kilograms of lunar soil to Earth, installed scientific instruments, and proved that a human is capable of working on the surface of another celestial body. In December 1972, as the Apollo 17 crew was leaving the moon, Mission Commander Eugene Cernan said, "We leave as we came, and God willing, as we shall return." After that, humans never returned to the moon. And here we come to the favorite question of conspiracy theory supporters: why humanity has not returned to the moon for more than 50 years? By the early 1970s, the main goal had been achieved. America had proven what it strove for. technological superiority. The political effect was obtained, and the program was extremely expensive. Each launch of the Saturn V cost unthinkable money for those times. Today it would be billions. After the first landing on the moon, each new return looked less and less impressive. People asked, okay, you flew again, what next? There were no new sensational achievements. Public interest disappeared, which meant less support, less funding, and less motivation. The country switched to the other problems. The Vietnam War, economic crises, social reforms, and space was no longer the main priority. That is how the end of the Apollo era came. The USA chose a different path instead of the moon. NASA placed its bet on reusable space shuttles. The idea was simple: cheap, regular flights into orbit, satellite maintenance, and scientific experiments. The shuttles flew often, but they couldn't physically reach the moon. The focus shifted to Earth orbit, the ISS, satellites, scientific missions. Why returning is harder than flying there for the first time? 50 years have passed, but technology is not only about progress. As it turned out, it is also about the loss of knowledge. Many blueprints, production lines, and technologies of the Apollo era were lost, destroyed, obsolete, and closed. Factories stopped producing engines. And also engineers of that era retired or became part of the history. NASA had to start almost from scratch. Safety is now more important than heroism. In the 1960s, risk was a part of the game. Astronauts flew in a rocket that, in terms of reliability, resembled a firework with a cabin if compared to modern safety levels. Today, there are different standards. Dozens of checks, years of tests, risk minimization. Modern missions take much longer time to prepare because the space race is gone. The politics has changed too. Today, no global race, no urgent threat, no time pressure. And without pressure, projects stretch for decades. Paradoxical, right? In 1969, as I already said, humanity just needed to get there. But now the goal is to build a system for long-term presence. Bases, resources, preparation for a flight to Mars. And this is no longer a jump. It is a long-distance run lasting decades. After the completion of the Apollo program and the era of the space shuttles, NASA found itself in a strange position. On the one hand, they had huge experience, but on the other, there was no big goal and a global challenge beyond Earth orbit to strive for. The ISS was working, satellites were flying, scientific missions studied the solar system, but humanity no longer left the near-Earth space. The Constellation program was announced in 2004 by the George Bush administration and was intended as the next US step after the shuttles, with the goal of returning humans to the moon by 2020 and preparing future missions to Mars.
We will give NASA a new focus and vision for future exploration. We will build new ships to carry man forward into the universe, to gain a new foothold on the moon, and to prepare for new journeys to the worlds beyond our own.
In 2009, the Augustine Committee revealed that the program funding was insufficient and the stated deadlines were unrealistic. The Constellation program was cancelled in 2010, but key technologies continued to be developed. In 2017, the USA again placed its bet on the moon and officially established the Artemis program in the same year, 2017, under the Donald Trump administration. Several important components were inherited by Artemis from the previous Constellation program. Orion, the super heavy rocket concept, focused on sustainable lunar infrastructure. The reasons for all this were not only scientific, but also geopolitical and economic. China started an active lunar program, and the moon means prestige, technology, and resources. Elon Musk's vision of flying to Mars also influenced the program, and the moon is the ideal proving ground for a flight to the Red Planet. The name was also not chosen by chance. In Greek mythology, Artemis is the sister of Apollo. If Apollo was about the first step, the Artemis is about the return in the future. Unlike Apollo, the new program sets more complex tasks: sustainable presence on the moon, base at the South Pole, extraction of ice. Ice means water, which means oxygen plus fuel. And of course, preparation for Mars. There is no longer just a mission. It's building an entire infrastructure, which requires more time and resources. The first uncrewed launch with the Artemis I mission was carried out on November 16, 2022. The launch was conducted from the Kennedy Space Center. After 25 days in space, Orion successfully splashed down in the Pacific Ocean on December 11, 2022. The goal of the Artemis I mission was to demonstrate the operation of integrated system as well as testing the Orion thermal protection system. Now let's talk about SLS. SLS is a super heavy lift two-stage rocket, created specifically for flights beyond Earth orbit. Its main task is to deliver the Orion spacecraft, crews, and cargo to the Moon and beyond. It is NASA's most powerful rocket, as I said before. The rocket consists of three main elements. The core stage of the SLS rocket reaches 65 meters in height and 8.4 meters in diameter. It is equipped with 4 RS-25 engines from the Rocketdyne company, which were previously used on space shuttles. It uses liquid hydrogen as fuel and liquid oxygen as an oxidizer. The RS-25 uses a closed-cycle scheme. Second element, side boosters, SRB, two giant solid fuel boosters. They provide most of the thrust at launch. Height about 54 meters. They work for about 2 minutes, then separate. They have 25% higher thrust compared to shuttle boosters, but they are disposable. Upper stage, used for putting Orion on a trajectory to the Moon and for precise maneuvers. In future versions of SLS, it will become even more powerful for heavy loads. The rocket has few configurations. Total height of the rocket in Block 1 configuration 98 meters, for Block 1B configuration 111 meters, and up to 111 to 150 meters with improved boosters in Block 2 configuration. Diameter 8.4 meters. Launch mass 2,600 tons for Block 1. Payload mass to low Earth orbit up to 131 tons. In terms of launch thrust, it is a second only to the legendary Saturn V of the Apollo era. At the very top is the Orion spacecraft. This is a joint development of the USA and the European Space Agency. Orion is a capsule for 4 astronauts designed for flights to the Moon, to lunar orbit, and potentially to Mars. It is a deep space ship. The diameter of the Orion spacecraft is 5.3 meters or 16.5 feet, and the mass of the spacecraft is about 25 tons. The internal volume of Orion will be 1.5 times larger than the internal volume of the Apollo spacecraft. The cabin volume of the Orion spacecraft is about 9 cubic meters, and this is not the total volume of the airtight structure, but specifically the space free of equipment, computers, seats, and other filling. The ship is equipped with a toilet. Main modules of Orion consist of few parts. Common module. Here are the astronauts, control systems, thermal protection, and parachutes. Service module. It provides electricity, water, oxygen, cooling, and thrust. And few words about the heat shield. The heat shield is one of the most critical elements of Orion. The ship returns to Earth at a speed of 11 km per second. This is faster than the shuttles and Crew Dragon. Entrance temperature about 2800 Celsius. The heat shield must not burn up, not collapse, and protect the crew. Artemis I showed that the system works, but areas for improvement were identified. Orion is designed for up to 21 days of autonomous flight, long-distance missions, and has radiation protection. This is critically important because in deep space there is more radiation and less protection from Earth's magnetic field. The risks are higher. Orion is equipped with an emergency escape system, the possibility of emergency separation, and all sorts of backup systems. In case something goes wrong, the crew can be pulled off the rocket, even at launch. Why they don't use Dragon or Starliner? Because they are designed for orbit. They don't have protection for deep space, they are not suitable for lunar trajectories. Orion was created specifically for the Moon. Another element of the Artemis program is the Lunar Orbital Platform, Gateway. The current idea for this project involves building a multi-module station that will rotate around the Moon. The station will be located in a halo orbit, where the minimum distance from the lunar surface is about 3,000 kilometers, and the maximum is about 70,000 kilometers. The station will make one revolution around the Moon in approximately 7 days. NASA views Gateway as a key infrastructure platform for Artemis missions. It will serve as an orbital transfer point, a scientific laboratory, and a support point for crews flying to the Moon and back. Why is the process too slow? Well, here it's like always and everywhere. Bureaucracy, politics, contracts, tests, safety, technical problems, and COVID also spoiled the plans. The most important event of this year in astronautics, and possibly in the 21st century, the Artemis II mission, which should return humans beyond Earth orbit for the first time since 1972. Unlike Artemis I, real astronauts will be on board. The goal of the expedition is to fly around the Moon and check whether the SLS plus Orion combination can safely deliver the crew to the Moon and return them home. Why is Artemis II critically important? Without this mission, the system cannot be certified. People cannot be sent for a landing. The future of the program cannot be built. 4 astronauts will be on board. Reed Wiseman, Mission Commander. Victor Glover, Pilot. Christina Cook, Mission Specialist. Jeremy Hansen, a representative of Canada. This is the first lunar mission with a woman and for the first time with a Canadian astronaut on board. NASA emphasizes, the Artemis program is international. The Orion spacecraft will spend about 10 days in space, according to NASA's plan. Start from Earth. The launch will take place from the Kennedy Space Center in Florida. The SLS rocket will leave the Orion spacecraft. The next step is system check in orbit. After entering orbit, the crew will conduct engine checks, life support tests, navigation check, communication with the Earth. This is the last opportunity to return while the ship is still close to the planet. Next, Orion will perform a maneuver, acceleration to the Moon. The ship leaves the near-Earth space and sets off into deep space. From this moment, the crew is outside the Earth magnetic field, is exposed to radiation, is in a completely autonomous environment. Then flight to the Moon. The transit will take approximately 4 or 5 days. On this step, the astronauts test systems, work with equipment, conduct experiments, check living conditions. Orion will not enter lunar orbit. Instead, it will perform a free return. What does this mean? The trajectory is calculated so that the Moon's gravity turns the ship without active engines, and it automatically flies back to Earth. This is the safest option. If the engines fail, the crew will still return home. During the flyby, Orion will be farther from Earth than any crewed spacecraft in history. The maximum distance of Orion from Earth during the lunar flyby will be approximately 432,000 kilometers, when the ship is on the opposite side of the Moon from Earth. This is a record distance. For comparison, the Apollo 13 record stood at about 400,171 kilometers from Earth. After the gravity maneuver, Orion will head back to Earth. The flight will take another 5 days. The crew will continue medical tests, radiation monitoring, physical condition assessment, and the final step, re-entry. This is the most dangerous stage. Orion will enter the atmosphere at a speed of about 40,000 km per hour. Temperature up to 2800 Celsius. Orion's heat shield must withstand this hell. It uses a composite epoxy silicate ablative material called F-coat. It consists of small tiny spheres made of phenyl formaldehyde, resin embedded in an epoxy matrix. When Orion enters the atmosphere, the air in front of the ship is compressed. F-coat chars and evaporates, thereby absorbing heat and removing it from the hull. This is the process of ablation. The material is eaten away, but protects the ship. It is located on the bottom of Orion, which is the part that meets atmosphere first. And now, final stage is the splashdown in the ocean. After deceleration, parachutes open, the capsule splashes down, the crew is evacuated. The landing of Artemis III with the crew on the Moon in middle 2027. The docking of Artemis IV with the Lunar Gateway in September 2028. And then future annual landings on the Moon. If Artemis II succeeds, the next step is Artemis III, planned for 2027. How are they gonna launch astronauts in a year if they need Starship HLS, which is not ready yet? We all know that. I hope it will be ready in a year, but I have some doubts, so we'll see. The Artemis III landing module is the version of Starship from SpaceX. It will not be a small module like in Apollo. but a huge flying skyscraper with a massive fuel reserve, with the ability to carry cargo and potentially reusable. In short, a lunar track. Now let's talk about money. The program's expenses have already exceeded $90 billion. The cost of just one SLS rocket is $1.6 billion, and one launch to the moon costs $4 billion. This is more than the budgets of many space agencies combined. Many criticize the SLS, calling it too expensive, outdated and inefficient. But I think it has advantages. It exists, it flies, and it's certified for cruise. Why has the moon become important again? In the 21st century, the moon is of course about geopolitics, prestige, resources, technology, and preparation for Mars. We still look at the moon as humans have for thousands of years. But in 2026 we have a chance, not just to look, not just to return, but get back and establish a long-term presence. I thank everyone who watched this video, guys. This is my first video in English. I'm trying to make content in a language what I don't speak good. I'm trying. Thank you for watching. See you soon and bye.